Calculate the standard cell potential produced by a voltaic cell consisting of a nickel electrode in contact with a solution of ionic nickel and copper electrode in contact with solution of copper ions. Which one is anode, which one is cathode, and obviously we need to find out the cell potential. So let's write down the half reactions. Ionic nickel in aqueous solution plus 2 electrons is going to produce nickel in solid phase, and ionic copper in aqueous phase plus 2 electron is going to give us copper in solid phase. So the standard reduction potential for the first one is negative 0.26 volt, and for the second one is going to be 0.34 volt. When we are dealing with cathode and anode, cathode is where reduction happens, and anode we have oxidation. Reduction happens where we have a stronger oxidizing agent. How do we figure out which one has more oxidizing agent power? We need to check these two numbers. Whoever has the largest number, it is more stronger oxidizing agent. So this one is greater than this one, so it's 0.34 compared to negative 0.26. So this one is greater, and it means that that's a stronger oxidizing agent. So this one is going to be the cathode, and this one is going to be the anode. So standard cell potential can be calculated using this formula, equals to standard reduction potential of the cathode minus standard reduction potential of the anode. And for both of them it has to be reduction, which you find it in table called standard reduction potential, which I already wrote the corresponding numbers. So cathode is 0.34 minus negative 0.26. So that's going to be 0.34 plus 0.26. That's going to be 0.6 volt. So that's going to be the standard cell potential for this cell.